Okay, Assalamualaikum everyone. Welcome back to Introduction to Electrical Power System. Today we're going to continue our subject about boost converter. Okay, so when you are told about boost converter, so automatically you know boost is always about step up. When you have 5 volt at the input and then I say that I want to boost my 5 volt. Okay, for example, you want your output to be 10 volt. Okay, so that is a boost. So means that your output voltage is actually more than your input voltage. Okay, that's why it's called step up or a boost converter. So this is the configuration of a boost converter circuit. This configuration is very important. Okay, so you know that inside the boost converter, you have a inductor, which is the L. Okay, you have a S is a switch, D is the diode, C is the capacitor, and then RL is the load. And you have the output voltage and also the supply voltage. Alright, so in the boost converter, sorry. Okay, in the boost converter, you know the circuit is made up from L and a switch and also a diode and also a capacitor. Oops. Okay, and connects to the output. Okay, so V minus plus minus. Okay, that's the Vs. We have the output there. Sorry. Okay, so in the step converter, you have two modes. Okay, one mode. Okay, this depends on these two modes. Yeah, when the switch is on, that's the first mode, and when the switch is off, that's the second mode. Okay, I call this mode 1 when the switch is on, and I call when the switch is off as mode 2. Okay, so where's the switch? So here's the switch. Okay, so this is the switch. I label it as S. Alright, okay, so since boost converter has two modes, we're going to have a look at when the switch is on and also when the switch is off. Okay, right. So in this slide is when the switch is actually on. Okay, so when the switch is on, you can see that it's a short circuit. Okay, it's closed. Alright, so this is when the switch is on, when the switch is closed. So what happened here at the diode? Automatically, okay, the current at this junction will see that there's two paths. Okay, so one path with no resistance. Okay, of course the current prefer that path, and then that will make the diode act as a reverse bias. So when the diode act as a reverse bias, the diode will become open. Okay, so this is what we're gonna go and we draw again the circuit. Okay, so you have your Vs, your supply here, and you have your inductor here, and then again the switch now become short circuit, so you just draw a straight line. Okay, now your diode is a open, it's a reverse bias. Okay, so it become a open circuit. Okay, then you draw your load. Okay, that's your you label as plus minus. Okay, output voltage. Okay, so this is your L. This is your plus minus VL. Okay, all right. So do you still remember your KVL? Yeah, Kirchhoff voltage law. All right. So from the above loop, you can rewrite Kirchhoff voltage law equations by having Vs, okay, VL plus V up. Okay, right guys. So here you can see that now it's become open circuit. So means that the V out is now 0 because of the open circuit here. Yeah. Alright. So when there's an open circuit, automatically the V out is 0. And you can say that the Vs equals to the VL. Alright. Okay, so that is the first equation that you get from the circuit. Okay, the second equation, do you still remember these equations? Okay, V equals to L DIL divided by dt. I believe many of you still remember. Okay, alright, that's in terms of time. Okay, right. So if you reshuffle the equations, okay, you now says that the VL now, okay, equals to the VS, right? Okay, so now let's assume now the VL is actually a VS. So VS divided by L, so means that you just bring L to the side and you get in terms of DI over dt. Okay, that is another equation. Okay, so this is very important. Okay, the equation number 2 is very important because this indicates the slope. Okay, so the slope of the IL. Okay, so this indicate is positive, so it's indicate the slope of a IL. Okay. Alright, so later we're gonna draw a waveform, so you're gonna have a look, okay, at the overall waveform. Okay, so that is for, okay, this is during the switch is on. Okay, this is mode 1. Okay, so next slide we're gonna have a look when the switch is off. So we're gonna have a look at mode 2. Okay, so now the switch is off. Okay, so at this slide, okay, it's mode 2, you will see that now the switch become open. Okay, so what it means by open means it become a open circuit. Alright, so at this time, you will see that the diode again, have a look at the diode. So now the diode become a forward bias. So when the diode become forward bias, what will happen is it will conduct current. It will allow current to pass through it. Yeah. So you will see here, if I label, okay, the current across the diode as ID, okay, and then the current across the switch as IS, okay, alright, sorry, IS, okay, that is the switch current. So you will see, you will agree with me that IL now is equal to ID. Yeah? Because they are in the same path. Alright? Okay? So now IS become what? IS is 0. Okay? Because now this become open. Alright. Okay. So we're going to continue on, okay, to derive the circuit. So let's have a look when the switch is off. Okay, so that is mode 2, yeah. Okay, let's redraw the circuit again. I'm sorry, it's hard to draw using tablet. Please bear with me. Okay, right. So now the diode become forward bias, so it's a straight line. And now you can see the switch is open. Okay. So now, okay, connect to the load, plus minus, V out. Okay, right guys. So let's do this circuit. Again, this become plus minus VL, still the same. Okay, and then the IL is flowing that way. And of course, there's an ID there. Okay, alright. So from the loop, okay, we derive again the KVL. Okay, this time Vs equals to VL plus V out. Okay, good. So if I want in terms of VL, it will become Vs minus V out. Okay, alright. So do you still remember VL? Sorry. VL equals to L DIL divided by dt. Yes. Okay, so that let's replace VL with the equation Vs minus V naught and bring the L to this side and you get di L divided by dt. Okay, you have to remember this is a boost converter. Okay, so with a boost converter, the V out has to be always bigger than the Vs. Okay, so means that this always has to be bigger than 0. Okay, so means that if I write it here, okay, it has to be, sorry, less than 0. Okay, so means that the slope for the IL later, you will see that is negative. Okay, so this is the slope. Okay, right. Next, we want to do the boost converter waveform.